Hello friends, this is my third lecture. I am Professor Ankit Kumar Shrivastava. This is my third lecture on feedback network. So here is I'm going to discuss type of feedback. So type of feedback, there are four different combinations in which negative feedback may be accomplished. So first one is voltage series feedback, voltage shunt feedback, current series feedback, and current shunt feedback. So now I'm going to discuss voltage series feedback. This is the block diagram of voltage series feedback. Uh, Here is the feedback and the sampler. So sampler, we are going to sampled with parallel. We are taking the series combination and series connection with the feedback and parallel connection with the sample to the feedback network. Here a block diagram of the voltage series feedback is, so the input to the feedback network is in parallel with the output of the amplifier, and the fraction of voltage output to the feedback uh, is series with the input voltage. So where in input, if we are talking about the voltage here, so if we connect the network in series with input, it is voltage, and if parallel we will connect, this is also the voltage denoted as a voltage. So here the output and input both are in voltage form. So in this case, the amplifier is a true voltage amplifier, and the output feedback voltage factor is given by beta is equal to Vf, where Vf is the feedback voltage and V naught is the output voltage. So now the input and output analysis of the network. So here we connected the voltage source uh, and the resistance, input resistance, and this is input voltage, and this is uh, voltage gain, which is open loop voltage gain, and this is voltage input voltage, and this is R naught, and this is RL. So we can summarize with this equation. We can apply the KVL of this network. So after applying the KVL, we will find this equation: Vs is equal to Vi plus Vf, and Vi can be written as Ii Ri plus beta V naught. Now just Ii and Ri will be in common, and A1 plus A beta is, so Ii Ri is the Vi, so we can just Vs and Ii and Vi. So RIF, this is feedback resistance, so RIF is equal to 1 plus A beta Ri. So here hence the input resistance of the voltage series feedback amplifier is given by this equation, And so Ri is the input resistance of the amplifier, and now ROF, output voltage of the feedback network, is V over I. So also next, and we can apply the KVL. So Kirchhoff voltage law of this network, and we will find out. So AV VI plus I R naught plus V naught, and we can summarize this equation: V naught over I is equal to R naught upon 1 plus A beta. So here we can find out the output resistance of the voltage series feedback amplifier is given by this equation, and where R naught is the output resistance of the amplifier. So in summary, we can say the input resistance is increased by the factor of 1 plus A beta, and output resistance can be decreased by the factor of 1 plus A beta in voltage series network. So first of all, here how can we write the voltage series? Here the input is the feedback network is connected to series with input and connected to parallel with the uh, output. So if we connect the output in parallel, then it is voltage, and if we connect the output in series, it is current. And same as if we connect the input in series, then it is voltage, and if we connect the input in parallel, it is current. So we can just read out this function. This is voltage series, and this is voltage series. So and also we can also write the voltage feedback. Voltage series also can be write voltage feedback. So next we will discuss voltage parallel in next lecture. Voltage parallel feedback, so or voltage shunt, we can say voltage shunt feedback in next lecture. So you can continue with my lecture. Thank you.